Hello, welcome back to the Joy of Code. This is Michael again, and today we will talk about a very important topic, and that is object interaction. We've talked about that a bit before, but there's much more to say about this, and we need to gain a deeper understanding. And today we will look at how to set up object structures so that they can interact. I will use the counter example for this that we have started last time by integrating the counter into a project. Remember last time we have created this counter class where I can construct a counter object and put it in here, and then I can right click on it and call the add score method and it counts up. So we have created a functional counter class of which we can create counter objects, but we have not integrated that, so the counter isn't actually used when anything happens. To integrate that, this bounce example is maybe not the best scenario to demonstrate this, so I will demonstrate that with a different scenario, and this one we have seen before as well, that we have seen the scenario here when we discussed the smoke effect. So I have copied my counter class here by just creating a counter class here and copying the source code across, using copy and paste from the editor. So I have here the same counter class. So I can now add my counter here into this class. I've changed the color to black so that because on this background it is better visible, and I can now call my add score method here, and that counts the score up. But as before, this counter is just as it was before. It is not integrated into this project. So if I reset this again, the counter is gone, and if I now start playing my game, there's no counter object being created yet, and there's no counting going on. So that's what we're going to do today. So the first thing I have to do is to programmatically place the counter into the world. So the way I do that is I added my world class, because an object of this class is created on every time before project startup. So here's my constructor. That constructor is executed when the world is created. So we can see here it creates a pedal and places that pedal into the world. So here we can create a counter. We will keep the counter in an instance field because we will need it later. So I need an instance field of type counter, and so this is the type of my variable, counter with a capital C, and I also call it counter. It's sometimes a bit confusing at first, this counter with a capital C is the type, that's the class, and this is the name I give to my variable. So here I'm creating a variable for storing a counter, and there I store a new counter object into this variable. So I create a counter and I store it in here, and then I add the object add my counter to the world, and then the question is, what should the coordinates be, where I want to place it. An easy way to find that out is just to do it interactively. Create a counter here and put it in and position it where you want it. Let's say I want it here. Do it manually first, and then inspect the object and inspect the coordinates and see this is now 113 and 23 are the x and y coordinates at the moment. Let's use those, 113, 23. That looks good enough. So let's programmatically place it there, 113, 23. So there is my counter object. So now if I compile my class and this counter here is created automatically, and I can now play my game. The counter is there now, but of course no counting is happening now. I don't want to create any bricks here yet to complete my breakout game. What I want to do simply at first is every time this ball bounces off the pedal, I want to add my score. I want to add 1 to my score. It's the ball that recognizes the bouncing thing. So if we look at the ball class and we see here's the act method, it says while the ball is not stuck on the pedal, it moves and makes smoke and checks whether it's gone out at the bottom of the screen. So let's look at the move method. This changes the location, so that's the actual moving of the ball. And then we check whether we hit the pedal with the check pedal method. Let's look for that method. Here's check pedal. Here we check whether the ball intersects the pedal. And when it does, if the pedal is not null, then we have hit the pedal. We get into this if statement here if we have hit the pedal. So here is essentially in that if statement is where we want to add the counting. what's going on here is essentially changing the direction of the ball, and then we want to count here. Now, to understand how to do this, let's look at a diagram. It's actually a little bit tricky. Let's look at the situation that we have here with our objects. So if I want to let me try to take over here with my pen. The situation I have at the moment is I have at the beginning a world object, right? So there's my world object that I have at the beginning, and the world object creates the pedal. So I get a pedal object. There's my pedal object. Every actor object has a reference back to the world. You can get that reference with the call getWorld. So every actor can, and this one, the world class here, creates this object. The pedal object then creates a ball object. So we have a ball object that is involved here, and the pedal object creates the ball object. Then we also have a counter object. So here is my counter object, and the world stores a reference to the counter object. So we have these four objects involved in our situation as we have it at the moment. Now the ball object is the one that knows that it hits the pedal, and that's the one that now wants to count up the score. The counter object is the one that it needs to reach. Now the problem is that the ball object has no reference to the counter object. So the ball object cannot talk to the counter object. The ball object now needs to tell the counter to count up, but the ball object doesn't know that the counter object exists. It has, here is no connection here. So for the ball object to be able to talk to the counter object and tell it to count one up, the ball object needs a reference to the counter object. Now, the only one who has a reference to the counter object is the world. The world here has stored a reference to the counter object. Now, there are a number of different ways how we can solve this. We can either, well, because the ball object actually has a reference to the world object, because every actor has a reference to its world object, the ball can either ask the world object to tell the counter object to update, or the second possibility is that we give the ball object a reference to the counter object. I will talk to both solutions, but only through one solution today, and then the next one I do a bit later. So the solution that I will now present is that we give the ball a reference to the counter object. So we want the ball to have a reference to the counter here. So we want to create this reference. Now the question is, how does the ball get a reference to the counter object? It cannot get a reference out of nothing. It cannot just find the counter. So the way to do that is for the world to give a copy of its reference to the counter to the ball. Now the problem is that the world doesn't actually create the ball. The world creates the pedal, and the pedal creates the ball. So essentially what we're going to do is we get the world to create the counter, and then the world creates the pedal, and we make it so that the world gives the pedal a reference to the counter, and then the pedal stores it. So the pedal stores a reference to the counter, and then when the pedal creates the ball, it gives the ball a copy of the reference to the counter. So at the end, everyone ends up with a reference to the counter, and then the ball can talk to the counter. So this is what we are trying to do. Now let's go back to Greenfoot and try to make that happen. So here I can get that out of the way. So first of all, in the board class, that's our world, we need to pass a reference to the counter to the pedal, which means first thing we need to do is we need to create the counter first. So I move that up here. So we create the counter first. So we have now first created the counter and placed it into the word, and then we create the pedal, and we take the counter variable and we pass that in to the constructor of the pedal. So now when we create the pedal object that executes the constructor of the pedal, we pass in a reference to our counter object. Now of course this will not compile. If we try to compile this it will say, well, the pedal doesn't have a constructor that expects a counter. We just fix that by changing the pedal. We say, okay, the pedal now, we'll give the pedal a constructor where we say public pedal that actually expects a counter object. Let's call it count. So now we have a counter, and we create also a field here that can store the counter. And here, notice here I've called it counter, here I've called it count. So the parameter is called count, the field is called counter, and then here I can write this, which takes my parameter, that's the reference to the counter, and stores it in my counter field. So now we have done, the first bit. We have given, after creating the counter here, we have passed the reference to the pedal, and the pedal now also stores a reference to the counter. So we have done the first bit. Now we need to do the same again to the ball. The pedal needs to pass on the reference to the ball, because the pedal now has a reference to the counter. And then there is this new ball method that is called every time when the pedal creates a new ball. Here, now, when a new ball is created, we pass on a copy of the counter reference to the ball, and we get the same effect when we try to compile that. That doesn't work because it says, well, the ball doesn't have a constructor that expects a counter. So let's give the ball a constructor with a counter. So here we say public ball, and then we do exactly the same thing. We say the constructor should receive a counter that we store in a parameter called count, and then we have a field called counter, and we store our thing in there. Oh, we already have a let me put that here. Private counter. So the fact that we already have an integer here called count, and here our counter object is called count in the parameter, might look a bit confusing, but it actually does work. That is legal. We can have a parameter that takes the same name as a field, as long as we don't try to use the field at the same time in this method. So this will actually here correctly copy the parameter into that field counter, not this field here. Although if I want to make that clearer and avoid confusion, I could rename that. I could just call that new counter, and here write new counter, just to avoid using the same name for two different things. Even though it would work and it is legal, it is a bit less confusing if I don't reuse the same name. So for readers, it's a bit clearer what's going on. So now the ball receives a reference to the counter when it gets created, and it stores this reference to the counter in its instance variable. And now we are at the situation where we have this reference here. So this reference here, from the ball to the counter, we now have it, and now the ball can talk to the counter. So here in the method where we have hit the pedal, we can now talk to the counter. Now we can talk, say, counter dot, and do code completion and see, have a add score. That's the method of the counter that counts the score. So now every time the ball checks the pedal and here notices this, yes, we have hit a pedal, it reverses its direction and then counts the counter up by 1. So let's try that out and start playing my game. And if things go well, there you see, every time the ball hits the pedal, my score counts up by 1. So this is how you integrate a counter into the game. The important thing to notice is here, the ball is the one that wants to count, the counter is the one that can count, and as long as they do not have a reference to each other, they can't talk to each other. For the ball to tell the counter to count up, the ball needs to have the reference, and to have the reference you somehow need to set up your object structures so that the references are the way you need them. So diagrams like that, knowing what objects you have involved in your scenario and who has a reference to whom and who talks to whom, is very important. So you should always have a bit of paper and a pen lying there and draw diagrams of your object structures. Okay, this is how to integrate a counter into a program. At least this is the first way. I will show you a different way in a later episode, but try this out first. Okay, that's it for today. Thanks for listening. Bye bye.